In this video, we'll be doing more examples on special triangles. So the first one, we have an isosceles right triangle, which means it's a 45, 45, 90. So the hypotenuse equals leg root 2. So x is the hypotenuse, equals 6 times root 2, and we're done. And the other leg is 6. Part B, we know the leg is 9 root 2, and we have another isosceles right triangle, so it must be a 45, 45, 90. So we can solve for x, which is the hypotenuse. I use my equation, x equals 9 root 2 times root 2, which is 9 root 4, and that gives us 9 times 2, which is 18. And we're done with that one. Example 2, find the length of x. Well, I have a square that has a diagonal that bisects the 90-degree angles, so I have another 45, 45, 90. The hypotenuse is the diagonal, so I substitute 12 root 2 for the hypotenuse and solve for x by dividing root 2 to both sides, and I get x equals 12. Part B, I have another 45, 45, 90. 16 is the hypotenuse, so I need to divide both sides by root 2. And then now we need to do something called rationalize the denominator. So we don't want any square roots in the denominator. So if I multiply top and bottom by root 2, it will cancel the radical in the denominator, because root 2 times root 2 is root 4, and then root 4 simplifies to 2. Boom. Perfect square. That comes out. 16 root 2 over 2. 16 divided by 2 is 8. Final answer, 8 root 2. Example 3. Now we have a 30, 60, 90 triangle. So the side opposite the 30 is the short leg, opposite the 60 is the long leg, and the hypotenuse is opposite the right angle. So my equation is hypotenuse equals twice the short leg. I make my substitutions. C equals 2 times 5, which is 10. Now I need to get the long leg, which is the short leg times root 3. So I make my substitutions. B equals 5 times root 3, and we're done. Part B, I have another 30, 60, 90 triangle. And F is the short leg, G is the long leg, 20 is the hypotenuse. So hypotenuse equals twice the short leg. 20 equals 2 times F. I divide both sides by 2, and I get F equals 10. So now we need to find the long leg, which is G. The long leg equals the short leg times root 3. G equals 10 times root 3, and that's it. We're done. So let's check with the Pythagorean theorem to see if this works. So I use a squared plus b squared equals c squared. I substitute my legs and my hypotenuse. 10 root 3 squared is 10 times root 3 times root 3, which is 300, plus 100. And we get 400 equals 400, check. Example 4, find the value of x and y. The x is the short leg, y is the hypotenuse, 24 is the long leg. So I use long leg equals short leg root 3, make my substitutions, divide both sides by root 3, and here we have to rationalize the denominator by multiplying top and bottom by root 3, which gives us 24 root 3 over 3, which is 8 root 3 for x. Now if I have the short leg, all I have to do is double it to find the hypotenuse. Y equals 2 times 8 root 3, which is 16 root 3, and that's y. Example 4, part B. I'm given the hypotenuse as 14 root 6. X ends up being the short leg and y the long leg. So we need to find the short leg first by using hypotenuse equals twice the short leg. And we divide both sides by 2, we get 7 root 6. Notice we can't divide 2 into the root 6. We can only divide it into the 14. Okay, so let's find the long leg. Long leg equals short leg times root 3. So we say y equals 7 root 6 times root 3. Now we multiply the radicals together. So I get 7 root 18. There's a perfect square factor in 18, which is 9. 7 times radical 9 times 2. Root 9 is 3. So I get 7 times 3 times root 2, which gives me 21 root 2. That's my final answer. Okay, next problem. Example 5. Find the measure of x and y. Let's add that on there. So I can take this trapezoid and break it up into a 45, 45, 90 triangle and a 30, 60, 90 triangle, because I know the square inside has 90 degrees and this 120 degree angle here means 90 plus 30. So I can use my 45, 45, 90 equation to find the legs, and that will give me hypotenuse equals leg root 2. Hypotenuse is 12, and my legs here are congruent, which we can call this z. So if I divide radical 2 to both sides, I have to rationalize as well. I get 12 root 2 over 2, which is 6 root 2. The 6 root 2 will also be the length of the long leg in the green triangle I've made. So if I substitute that into my equation, I can solve for the short leg, which I'm calling w. Divide both sides by root 3. And I have to rationalize this by multiplying root 3 top and bottom. Root 2 times root 3 is root 6, so I get 6 root 6 over 3, which simplifies to 2 root 6. Okay, so let's find the side x then. X is going to be these three segments added up together. So I've got 6 root 2 and the 20, and then w that I just found is 2 root 6. None of these are like terms because of the radicals, so I can't really combine them. Just leave it like that. Y is the hypotenuse of the green triangle, and all I have to do is double the short side. 2 times 2 root 6 is 4 root 6. Okay, example 6, last one. Find all unknown variables. So I have an isosceles right triangle here, so that must mean it's a 45, 45. So w has to be 3 root 2. Now to find x, the hypotenuse, all I have to do is multiply the leg times root 2. This is a 45, 45, 90, so I've got to make sure I use the right equation. So x equals 3 root 2 times root 2, which is 6. Now I can find y or z. I know this is a 30, 60, 90 triangle. So x is my short leg, y is my long leg, and z is the hypotenuse. So why don't we find the hypotenuse first, z, by using the 30, 60, 90 equation. Z equals 2 times 6, which is 12. Doubled the short side. Long leg equals short leg times root 3, so I take y equals 6 times root 3, and that's it. That's my final answer. Okay, so I hope that was helpful for you guys. See you next time.